Okay, welcome back. We're gonna be talking about the percent of change. Percent of change you'll find very frequently in the healthcare profession. For instance, let's say that your doctor asked you about your diet and found that your diet was 3,200 calories a day. So that would be your original caloric intake. And then your doctor said, you need to reduce that. I don't want you to eat more than 2,000 calories a day. Maybe you're in danger of being or borderline diabetic. So he wants you to reduce your caloric intake to 2,000 calories per day. What we're going to do here is we're going to set it up very similar to the proportion that we were using. The difference is that we're going to be looking at, we're going to say the change over the original. And it doesn't matter if you're talking about calories, if you're talking about intake of certain vitamins, if you're talking about your medication, if you're talking about weight. Anytime you're talking about change, it's the amount of change. In fact, amount of change over the original amount, and we're going to set that equal to a percent over 100. So as you can see, it looks very similar. Again, in fact, you may prefer to keep this on the left side so it's more similar to what you're used to working with. Your book does put it in this direction, and that's fine. We can do it either way. There's still going to be, you think of them as two equal fractions is basically all it is, equivalent fractions. So, and all we have to do is solve for an unknown. So let's take this here. What's my original weight? Or my original caloric intake was 3,200 calories. I'll put that down in the denominator, 3,200 calories. Okay, how much of a change is that? I'm pretty sure you can do that right in your head, but I'll go ahead and do that. 3,200 minus 2,000, and you have a 1,200 calorie change. I think we could all use some of that, huh? Okay, so if you have a 1,200 calorie change, we want to find out what percent of a change is that. So we're going to set that up over 100, and this time let's go ahead and use a C. Now looking at this here, again, all I have to do is cross multiply. I have 3,200C is equal to 1,200 times 100. 1,200 times 100, I've got my 1,200 and two more zeros. Work backwards, 120,000 equals 3,200C. Again, I'm solving for C, the opposite of multiplying by 3,200, divide by 3,200. This leaves C over here because 3,200 over 3,200 is just 1 or 1 times C. So just C. And here's where I got to do a little bit of math. Let me erase some things that we don't need anymore. Not much there. But I have 120,000 divided by 3,200. Let me see here. Let's try 3 times. Would I be putting that right there? So 3 times 0 is 0, 3 times 0 is 0, 3 times 2 is 6, and 3 times 3 is 9. Subtract that off, 0, 0, make that into a 1, this becomes a 10, 4, and 11 minus 9 is 2. 2,400, I'm going to bring down my next 0. I would recommend using a calculator if you were doing this for a patient. But again, on tests, you won't have access to a calculator, so it's good to know how to do even more difficult long division problems. Let me see, it won't go 8, but it should go 7 times. Let's try that. 0 and 0, 2 times 7, 4, carry my 1, and 22. End up with 0, 0, this becomes a 10, and this becomes a 3, so 6 and 1. Wow, this actually might work out pretty good. So I'm going to have to add a decimal point and another 0, extend that, bring down this 0, and this happens to just work out really nice and be 5. So my percent of change was 37 and 5/10, or 37 and 5/10%. Generally, it won't come out always that pretty, but that one did come out pretty nice. So quite often they'll have you round it to the nearest 10th or the nearest 100th place. Okay. We've got two more things to cover, but we're getting long on this video, so I'm going to go ahead and stop it again.